Hello everyone, welcome back to our channel. In today's video, we will be discussing about measures of dispersion part 2. Now, in our previous video, we discussed already the first part of measures of dispersion. We had discussed about the range and the mean absolute deviation. Now, in this video, we will be discussing about the standard deviation and variance. Okay, so what is standard deviation? So let's start with the key concepts. It is sometimes the average of the data. Sometimes the average of the data set doesn't do a good job representing the data. So a normal distribution of data means that most of the examples in a set of data are close to the average, while relatively few examples tend to one extreme or the other. So specifically, a standard deviation refers to how much scores in the data set tend to spread out from the mean. Now, the standard deviation tells the researcher how spread out the responses are. Like, it will answer the question, are they concentrated around the mean or scattered far and wide? So the standard deviation gives a sense of how dispersed or spread out the data from the mean. Now, to understand further the standard deviation or the concept of standard deviation, let's have an example here. Let's have three cases, for instance. Okay, you have case number 1, case number 2, and case number 3. So for considering that we have n is equal to 6, or number of cases or observations is 6, both 3 cases. So if we are asked in case number 1, now let's observe how do scores look from the mean. We have there the mean at the middle. So how do scores, considering the dots there, the 6 dots corresponds to the scores. So in case number 1, how do scores look from the mean? So we could say that the scores look clustered around the mean score. That's for case number 1. Now, how about in case number 2? How do scores look from the mean? Look at the dots, the 6 dots in case number 2. So what would be your answer? So answer would be scores are more widely spread out from the mean. Okay? So it's more widely spread out from the mean. As you can see, there are 2 scores that are below the mean and 2 scores also are above the mean. So let's proceed to case number 3. Look at case number 3. If you could see there, there's only 1 dot, but however, that there still there are 6 cases or 6 scores, meaning these 6 scores are of the same value. That's why you can only see 1 dot in there. That means they just overlap. So all scores are just the same with the mean. Okay? That's for case number 3. Now let's proceed to so we can picture out how does the standard deviation work. So let's have this table. Considering we have here 3 sets with corresponding scores, and we will provide the mean since you know already how to solve for the mean. So what is the mean for set A? Or compute the mean of set A. The mean would be, in order for us to solve for the mean, all you have to do is get the average or add the scores and then divide it by the total number of observations. So after solving, you will get 5. Okay. How about for set B? What do you think is the mean for set B? Okay, try solving. Then your mean would be still 5. How about for set C? What do you think is the mean? Remember, 5 the repeats. Okay. The mean of set C is also 5. Now, considering that the standard deviation is on the last column, let's just consider that the standard deviation is already solved. So we could picture out how does the standard deviation works in a data. Okay, so for standard deviation in set A, you have 1. For set B, you have 3.82. For set C, you have 0. So how does the standard deviation works in this table? Okay, so we will be discussing this one. So basically, okay, for a moment, basically it shows that the standard deviation will tell us how spread our data is from the mean. So for set A, as you can see, you have 4, 4, 4, 4, 5, 5, 5, 6, 6, 7. The standard deviation is 1. It means to say that the data is just clustered around the mean. It's just near to the value, which is 5. Then for set B, you have 3.82 as your standard deviation. As you can see there, in set B, the scores are widely spread. Like you have 1, and you have 2, 8, and 9 as the values. And for set C, since you have 0, a standard deviation, it means that the mean is the same, or the scores are exactly the same as the mean. Okay? So your standard deviation will be 0 if all the scores are of the same value as the mean. Now let's proceed to another example. So you have here, imagine you supervise 2 managers who sell pizza. Since you don't want any pizza to be wasted, it's important that these 2 managers hold a steady inventory. Taking the average of the last 6 weeks shows that each manager orders an average of 33.5 boxes of pizza per week. Now on the surface, the average make it look like they are performing equally. Now there are pizza orders per week. You have manager A, you also have manager B. Okay, take a look at the data. By the way, pardon me of the data for manager B. There's something wrong with my presentation. Then we have, just take a look at the data and the mean and the standard deviation. Later on in the next slide, we will still see the values on manager B. So don't worry. So as you can see on the mean, okay, for manager A and for manager B, for the mean, they have the same values, 33.5. Remember, the mean is one of the measures of central tendency that would actually represent the data set. So for manager A and B, their mean is 33.5. So even though you could see that their data varies widely, or the two data between manager A and manager B, okay, varies, but then, or differs from each other, but then they have the same mean. So we will going to look at the standard deviation. I know you don't know yet how to solve the standard deviation, but I'm just presenting this problem so that we could picture out and we could understand how standard deviation works in a certain data. So considering we are comparing the standard deviation between manager A and manager B, we have 0.96 for the manager A, and manager B we have 17.63. So imagine the big difference between the two. Okay? So let's proceed. The pizza orders per week for manager A. So let's focus on our attention to manager A. We have here the mean. So for manager A, we have 23, 35, 60, 52, 10, and 21. Then the mean is 33.5. The standard deviation is 17.63. 63. Now, if you look closer to the data, one of the managers has weekly orders of 23, 35, 60, 52, 10, and 21 boxes. Now for this, the average, okay, for a moment, the average may be mathematically correct between, but it hides the volatility or the consistency of these weekly orders. Okay, this is where the standard deviation comes in. By the way, that's actually the manager B's data, where the mean is 33.5, but the standard deviation is 17.63. Meaning, there were weeks which has an order of 60, and there are also weeks which has only 10. Okay? So meaning, there's no consistency on the number of orders on the different weeks. So we have here, for the pizza orders per week, the set A again is for manager A, and the set B is for manager B. So take a look at the data. For set A, 34, 32, 33, 35, 34, 33, with a mean of 33.5, with a standard deviation of 0.96. Okay? Then set B, 23, 35, 60, 52, 10, 21, with a mean of 33.5 and a standard deviation of 17.63. So in the case of the first manager, the standard deviation is only 0.96. This tells us that each data point in the sample sits an average distance of 0.96 statistical data points from the mean. Okay? So the data are clustered around the mean because that's only per 0.96. Okay? On the other hand, a standard deviation of 0 would say every data point is exactly equal to the mean, which is 33.5. So, a standard deviation of 0.96 is not far off from the indicating that majority of data points are positioned extremely close to the mean. The closer the standard deviation to 0, the more reliable the mean is. Okay? So, this is the importance of solving or knowing the standard deviation. Again, that means the closer the standard deviation to 0, that means the more reliable the mean is. Now, more than that, standard deviation close to 0 tells us that there is very little volatility in the sample. Okay? Meaning there is consistency in the sample. With a standard deviation of 0.96, that the first manager's weekly orders are remarkable consistent. So the manager A is consistent with his weekly orders, number of pizza orders per week. Now, in the case of the second manager, the standard deviation is 17.63. Now, the average distance each data point from the mean is 17.63 statistical data points, which is a huge spread. Okay. So, if you are the supervisor, okay, and there's two managers, which one would you choose? Which one is better for you? Okay? So, basically, it's actually the manager A because he or she is consistent. Okay? Now, let us proceed to the standard deviation formula. Now, the previous examples, we actually give examples of data with the given mean and the standard deviation So we could understand better how does the standard deviation works in a data. So we would understand the function of the standard deviation. We should not just merely learn how to solve the standard deviation, but we should know the purpose in solving the standard deviation. How does it help for us to picture out the kind of data we are having or we are handling? Okay, so let us now proceed to the standard deviation formula. Now the population standard deviation is defined as, you have that symbol for the population standard deviation is equal to, okay, we have here the corresponding, you have X is the individual scores in the population, and mu is the population mean. Remember, mu is the lowercase letter from the Greek alphabet, that's population mean. Then the capital letter N is population size. And the squaring the standard deviation, we obtain the population variance. Okay, so we have that. So just the standard deviation, and then if we square the standard deviation, we will just put square to the symbol for standard deviation. That will give us the variance, and just simply extract the square root of the formula for the standard deviation. So that is our variance, population variance. Well, the sample standard deviation, on the other hand, is defined as that one. The lowercase letter s is equal to the summation of, okay, so let's have the symbol and its representation. You have where x is the individual sample scores, and the x with the bar on top is the sample mean, and n, the small letter n, is the sample size. Okay, and for the sample variance, we have here in probability theory and statistics, variance is the expectation of the square deviation of a random variable from its population mean or sample mean. Variance is a measure of dispersion that take into account the spread of all data points in a data set. It is the measure of dispersion the most often used, along with the standard deviation, which is simply the square root of the variance. Now, so the symbol of the variance of a random variable is this one with a square. Well, the symbol of the empirical variance of a sample is S squared. Okay. Now, the sample variance S squared is the square of the sample standard deviation. That is, you have that S squared is equal to the summation of, okay, for a moment. Okay. The sample standard deviation, on the other hand, is defined as this one. Okay, we're done with this. Then this, okay. Okay, you have here X is the individual sample scores, sample mean. This is still the standard deviation. We're done with this part. And then we have, okay, let's have an example. Okay, for a moment. Okay, the sample variance S squared is the square of the sample standard deviation. That is, if you're, since we already have the formula of the standard deviation, since it's the sample variance or the sample standard deviation, we will just going to square the formula of the sample standard deviation. So we have that formula for the sample variance. Now let's have now an example. Now consider the following levels of 17 ketogenic steroids or urine measured in milligram per 24 hours of 5 men. You have 8, 6, 3, 4, and 4. Let's try to compute computation if this were taken from population. So we have to always bear in mind if we are given the population or sample data. Okay. Since it's population, we will be using the population mean. So we have the symbol for the population mean. That's mu. Again, that's the lowercase of the Greek letter alphabet, which is which represents or symbolizes the population mean. So we'll get that's 8 plus 6 plus 3 plus 4 plus 4 divided by 5. We get 25 divided by 5. Our population mean is 5. Okay? After which, we are going to write down all the result in our X. That's our observations. And the population mean, we have 5. We'll write it all throughout. And the X minus the population mean, we have 8 minus 5, that's 3. 6 minus 5, that's 1. 3 minus 5, that's negative 2. 4 minus 5, that's negative 1. 4 minus 5 for the last row is negative 1. Then on the fourth column, we are going to square X minus population mean. So we have 3 squared is 9, 1 squared is 1. Quantity negative 2 quantity squared is positive 4, negative 1 quantity squared is 1, and here is also 1. Okay. Then we're going to get the summation. That's 9 plus 1 plus 4 plus 1 plus 1. That gives us 16. Okay. Thus, our standard deviation formula, we are now going to simply substitute the value. So we have the population standard division is equal to the square root of 16 divided by the population, population size, which is 5. So that gives us square root of 3.2. Then the population standard deviation is 1.79. On the other hand, our variance would be, if our standard deviation is square root of 3.2, our variance, we're just going to square both sides of the equation. So we have our population variance is equal to the quantity of square root of 3.2 quantity squared. So you get our population variance is equal to 3.2. Okay. So we actually solved already the population standard deviation and the population variance. I hope that is clear. Okay, let's proceed. However, if 5 men were taken as samples, then we have, let's consider if it is sample, the same data given. We will be using the same data. So you have sample mean. Since a while ago we're using the population mean, now this time it's sample mean. We will be using the symbol for the sample mean. So we have the same result because we're using the same data. Then we're going to place it on a table, write down all the cases, and then we have our sample mean is 5. So we obviously get the same result, only that we use the symbol for the sample mean. Okay, the same procedure. Okay, and then proceed to the formula. Since we're talking about the sample standard deviation, we will use the small letter s, and you have that formula. And our n is in lowercase because we presume that we are dealing with the sample data coming from the sample. So you have here, so you have the sample standard deviation is equal to the square root of 16 over 5 minus 1. Then that is standard deviation is equal to square root of 16 divided by 4. Our sample standard deviation is square root of 4. Then our s is equal to 2. Okay. Or the sample standard deviation can directly computed without computing the mean. So it is an alternative way on solving for the sample standard deviation without computing the mean. Now this is the formula. So this is given by the formula. The sample standard deviation is equal to the square root of n, the summation of x squared minus the summation of x quantity squared, all over n times the quantity of n minus 1. So as you can see in the formula, there's no mean. Okay. So all you have to do is provide the data on this table using this method. So you have that x, written all the observations. Your summation of x is 25. And then you square the values of x. You have 8 squared is 64, 6 squared is 36, 3 squared is 9, 4 squared is 16. Okay, the same value for the last row. Afterwards, you're going to get the summation of x squared. You have 141. Okay. Then you proceed to the formula. So you have your sample standard deviation, your n is 5, your summation of x squared is 141, minus your summation of x is 25, then quantity squared. You just follow the formula. Then you have your n is 5 again, times the quantity of 5 minus 1. So you got square root of 705 minus 625, all over 5 times 4. That is 5 minus 1, that's 4. And then you have the sample standard deviation is equal to 80, square root of 80 divided by 20. That gives us square root of 4. Okay, so our sample standard deviation is 2, which is the same as our result of the sample standard deviation using the previous formula or method. Okay? Okay. Now this time, we will proceed to the sample standard deviation of a grouped data. Now I hope that solving the population and sample standard deviation as well as the variance for ungrouped data is already clear. Okay? So now we will proceed to the sample standard deviation of a grouped data. Now, for group data, the sample standard deviation can be approximated by using the formula. We have that one, that sample standard deviation is equal to the square root of f times the quantity of x minus mean squared all over n minus 1. Okay? Always remember that if we are getting the sample standard deviation, when we talk about sample, we will be using the symbols for sample. Okay, for the standard deviation we will be using the small letter s, and for sample size we will be using the small letter n. Okay, and of course for the sample mean we will be using the x with the bar on top. So everything follows if we are solving for the sample. Like if we're solving for measures of central tendency, if we're dealing with the sample, the data coming from the sample, we will be using all the symbols intended for the sample. The same thing for the population. Okay. So we have here where F is the frequency, then we have the sample mean, we have the class mark, and we have the number of cases, okay, or the sample size. So considering we have the classes, then we have the frequency given. So we will be dealing with this data for our in solving for the sample standard deviation of group data. So we have approximate the standard deviation of this given frequency distribution table. So this time we are going to complete the table. For the classes, we will just going to copy as well as the frequency, because these two columns are given. So we'll proceed to the class mark, or X is the class mark. Okay, we already know how to solve for the class mark. So we have, by the way, we're going to get the summation of frequency first. We have our N is 15 for our sample size. To get the class mark, we have, that is 10 plus 19 divided by 2, you have 14.5. Then 20 plus 29 divided by 2, that's 24.5. We have 30 minus 39 divided by 2, that's 34.5. The same procedure for 40 and 49. You just add, then divide it by 2, you have 44.5. Then you have 54.5. Okay? Then for the mean, the sample mean, you have, sample mean is the summation of fx over n. So we have, okay, so our sample mean is already solved. So just think that we just get the summation of fx, then divide it by the number of cases or the sample size. Then our mean is, for a moment. Okay, our mean is 27.83. So we will be writing 27.83 on the sample mean column. Now let's proceed to the next column. You have your class mark minus the sample mean. So you have 14.5 minus 27.83. That gives us negative 13.33. Then you have 24.5 minus 27.83. That is negative 3.33. Next is 34.5 minus 27.83. That gives us 6.67. Then we have 44.5 minus 27.83. That gives us 16.67. Then 54.5 minus 27.83. That gives us 26.67. Now at this point, we are going to square our result for the 1, 2, 3, 4, the fifth column to complete the sixth column. So we're going to square the result. You have square negative 13.33. We have positive 177.69. Okay. The same procedure, negative 3.33 square, you have 11.09. 6.67 square, you have 44.49. Then you square 16.67, you have 277.89. Then you have 26.67, you square that, you have 711.29. Then afterwards, we are going to multiply it with our frequency. So we have, okay, we're going to get the product for our frequency. So we have, frequency is 5 times 177.69. So you have 888.45. Next, 4 times 11.09. You have 44.35. Next, 3 times 44.49. We have 133.47. Then 2 times 277.89. We have 555.78. Then lastly, we have 1 times 711.29. We have 711.29. And then we are going to get the summation of the last column. The summation of f times the quantity of x minus the sample mean squared is equal to 2,333.34. Okay. Okay. So now, hence we have, okay, going back to the formula, you have that formula for the sample standard deviation for group data. Our n is equal to 15 and our We also have the value for the summation of f times the quantity of x minus the sample mean squared is 2333.34. Now, we see to it that we actually round off to the nearest hundreds. So our approximation value for our sample standard deviation will be near to the accurate value, okay, for accuracy purposes. Okay, so you have here the sample standard deviation is equal to the square root of 2333.34 all over 15 minus 1. So you have square root of 2333.34 divided by 14, and then you got 12.91. So that is our sample standard deviation. Okay. For group data, the sample standard deviation can also be approximated using the formula. So this is another method or another formula. You have that. The same as the sample standard deviation for ungrouped data. Okay? So where S is the sample standard deviation, N is the number of samples, F is the frequency, and X is the class mark. So let's try to check. Okay, the same classes, so we will be dealing the same, okay, we will be dealing with this using the same data. We will be just using the second method. So you have the frequency, the total is 15. Okay, and that's our class mark. And this is our, okay, x squared. We're going to square our class mark. So 14.5 squared, that's 210.25. Then 24.5 squared, that is 600.25. Then 34.5 squared, that is 1190.25. Okay, again, I'm going to repeat. So you have, we are going to square the value of x. So you have 14.5 square 210.25. Then square 24.5, you have 600.25. So 34.5 square, you have 1190.25. And 44.5 square, you have 1980.25. And 54.5 square, you have 2970.25. After which, we are going to get the product of our frequency and our x squared. We have, let's start from the bottom, 5 times 210.25, that gives us 1051.25. We will do the same procedure, okay, as we go up. So 4 times 600.25, we have 2,401. Then 3 times 1,190.25, we have 3,570.75. Then we have 2 times 1,980.25. We have 3,960.50. And then 1 times 2,970.25, you have this. 2,970.25. Okay. The next would be, we're going to multiply our frequency with our x or our class mark. So let's start from the bottom. That is, okay, for a moment. You have 5 times 210, 5 times 14.5, that is, by the way, before we're going to solve for the last column, we're going to get the summation of fx squared. So that is the summation now. We just add all the values on that column fx squared. Then now let's proceed to fx. So 5 times 210.25, 5 times 14.5, you have 72.5. Then 4 times 24.5, you have 98. 3 times 34.5, you have 103.5. Then 2 times 44.5, you have 89. Then 1 times 54.5, you have 54.5. Then after that, you are going to get the summation of fx. That gives you 417.5. Okay. Next, since we already have the values, we are going to go back to the formula for our second method, or in solving for the sample standard deviation for group data. This is the other method without solving for the mean. Okay, so we have here, we substitute the values. Our n, or sample size, or number of cases, is 15. Our summation of fx squared is 1395 wait, 13,953.75 minus our summation of fx quantity squared. Our summation of fx is 417.5. Then our sample size again is 15. Then you have substitute that for our value for n. So you have 15 times the quantity of 15 minus 1. Okay. Then you have square root of 15 times, okay, so we just simply copy the first one. Let's proceed. So that is 15 times 13,953.75. That will give us 209,306.25. And then 417.5 square, that will give us 174,306.25 all over 210. 210, we get that from 15 times 14. Okay, next. So we have here the sample standard deviation is equal to the square root of 35,000 divided by 210. So we have our value of our sample standard deviation is 12.91. The same. Okay. So it's up to you which one you are going to use, the first method or the second method, in solving for the sample standard deviation for group data. Now, you've noticed that in this method or in this procedure, we're dealing with large numbers, okay, compared to the first method. But again, it's still up to you on which method you are comfortable to use. Okay. So, let's check. Let's have a comprehension check for me to know if you understood our discussion in this video. I know it's a bit complicated compared to the previous videos, but I guess everything from the start, from the standard deviation of ungrouped data, as well as the variance, and the standard deviation of group data as well as the variance, are clear enough because I gave you examples in each. Okay, so for part 1, suppose the following data set represents the population values of the number of patients in a certain hospital for a 7-month period. Compute the standard deviation and variance. So you have month and number of patients. Okay, month and the corresponding number of patients. For first month, you have 380 patients. Second month, 450. Third month, 100. Fourth month, 560. Fifth month, 250. Sixth month, 420. Seventh month, 300. Now, consider the following sample values in the diastolic blood pressure of 6 hypertensive patients. You have 72, 80, 95, 85, 70, 65. Please compute the standard deviation and variance. Okay. So, please take note of the symbol you are going to use if it is population and if it is sample. Let's proceed to the next one. You have the following for the standard deviation of group data. Okay, part 3 or test 3, we have the following frequency distribution table presents sample systolic blood pressure of patients in a certain hospital. Compute the standard deviation and variance. So we have here the classes with the corresponding frequency. So 160 to 164, 2. 155 to 159, we have 8 as the frequency. 150 to 154, we have 5. 145 to 149, 5. 140 to 144, we have 4. Then 135 to 139, we have 6. Then for part 4, use the data above to compute for the standard deviation if they were taken as population. Okay, so you will be using the same data for part 3 to answer part 4. Okay, so I hope that everything is clear, and to end this video, let's have a math code. Okay, math is the only place where truth and beauty mean the same thing. So that's all for today, and thank you so much for watching this video. I hope you learned something, and don't forget to subscribe our channel, and well, see you on the next video. Bye.